so the lab, number 1, write a short program that asks for your height in feet and inches, and then output your BMI. The program itself, I'm just going to do this all over again. You guys can see it. The first thing I would recommend to do for this program is just to get all your data in a row. So I would get your feet, I would get your inches, and I would get your weight. And then what I would do is I would ask for each of those. So, and I would just do this one at a time. Just input your feet, and then I would copy this one for each one and replace each of these here with the things that actually change. So inches, what is your weight in pounds? And then just type in your weight. I would set up these 3 statements first. I'm going to adjust the color scheme real quick. Okay, so once you have all these 3, now you can start doing your math. So the first thing I would do is I'd create a new variable that is total height in inches. It's going to be equal to the feet that you typed in times 12 plus the inches that you typed in. This right here represents your feet and plus your inches. Then what you want to do is you want to convert this into meters. So total height in meters is equal to total height. Notice I'm being very verbose with my descriptions here. You can afford to be a little descriptive in your variable names. It helps you understand them a lot more, a lot easier when you type them like this. So now I know this variable represents my total height in meters, which is I think 0.0254. Let me just double check that. By multiplying by 0.0254. Okay. So now I have my height stored in meters because it's inches times this number here. I also need to do the same conversion for my weight to convert it into kilograms. So one thing here, I used an integer, which is actually incorrect. I'm doing a floating point operation here. Remember that integers can't represent decimal points. They can't represent fractional numbers. I'm going to convert this either to a double or a float, your choice. You can use either. Same thing for weight in kilograms. It's going to be equal to weight divided by 2.2. Okay? And these can either be doubles or floats, your choice. I'll use doubles just because. And then finally, what you want to do is calculate your BMI. And this is going to be equal to your weight in kilograms divided by your total height in meters squared, which means it's just this times itself. And then I will do this. I'm kind of curious. I want you guys to know about the mountain in Game of Thrones. What's his? Who's the guy that plays him? Portrayed by Hafthor Julius Bjornsson. I'm curious what his BMI is. He's 6 feet 9 inches tall, 395 pounds. That is kind of crazy. So if he is 6 feet 9 inches tall and 395 pounds, his BMI is 42. Okay. That guy is big. Okay. And that's how you solve this. So the easiest thing to do, really, you want to break this out into doing one step at a time. You want to calculate your height in inches. Then you want to calculate your height in meters. Then you want to calculate your weight in kilograms. And then you use those things to calculate your BMI. Notice I'm making variables for every single one of these. So it amounts to, you call cout to ask for height, inches, pounds. Store those into variables here. Do your calculations here. And then your BMI is your weight divided by your height in meters squared. All right, questions on this lab? All right. So let's do lab number 2, which was to type in a value in seconds and then get out days, minutes, hours. This actually should say 17 hours here. Okay. In addition, I asked you to use symbolic constants. So I asked you to make it easier for yourself by creating variables that represented like reusable values of time. Specifically, how many seconds are there in a day? How many seconds are there in an hour and a minute? We can even expand this to basically years, days, hours, minutes. Okay. So let's start over from scratch. I'm just going to delete everything I just did. Make sure I have a return 0 here. So let's first create some symbolic constants here. I want to say, hey, let's create an int that is how many, I'm going to do these in caps, seconds in a minute equals 60. Right? Let's create another one that is minutes in a hour. That's also 60. And then hours in a day, 24. Okay. That should be all we need for our seconds. Now let's create some more that represents seconds. So I'm going to say constant int seconds in a hour, which is equal to seconds in a minute times minutes in an hour. Okay. If you read this just in English, the number of seconds in an hour is equal to how many seconds are in a minute times how many minutes are in an hour. So this is basically 60 times 60. This is equal to 3,600. That's how many seconds there are total in an hour. Then we can do the same thing. We can make how many seconds in a day. What is this value equal to?
86400.
Okay, so that should be seconds in an hour times hours in a day. Okay, 86,400. So I have these values now, which is nice because if I look at it like this, I just have 3 variables, each telling me how many values I have. So I'm going to ask for, I'm going to create a final long variable called seconds. Okay. So let's start off simple. If you guys if you're ever stuck on a problem, you just have no overheads to start, it's like super overwhelming, it might be because you're trying to solve too much at the same time. What if I just simplified this problem to literally just spit out how many days there are? Right? If I literally just asked you for only the number of equivalent time in days. Okay? If I simplify the problem like that, I think I could do that problem pretty easily, right? Let's start with that. So let's create a variable that stores how many days. And the days is just going to be equal to seconds divided by seconds in a day. And then I'll just say days. What does this say? I'll just say, let's do this. Seconds equal to let's just start with that. Nothing else. I'm literally just doing this operation right here and run it. So if I type in 316, what was it? 316,000,000, 365 days. Cool. I got the same result as what the lab is. I didn't worry about anything else. I was literally just calculating how many days are left. Okay. I now have a place that I can start and think about how to solve this problem. And this problem really boils down to you being able to figure out how to use the modulus operator and the division operator together to break down this big number into smaller and smaller numbers. Okay, if I asked you how many days are in this number that I typed in, you could say 365, but how many seconds are left over after that? So if I type 300, if I divide this by the seconds in a day, which is 86,400, can you guys see this? I wonder if you can. It's kind of small. 365, this is what is typed in. This is how many days are in that number that I typed in, and here's the remainder of that. How much is this in seconds? What is 0.7040404 in seconds? How do I figure that out? Math. Well, what does this number represent? If I just typed in this number, this is how many seconds in a day I have remainder, but this is in a day format. If I take this number here, I multiply it by 86,400. So Sorry, I'll do it a little bit better. So I have 365.704. This is how much I have remainder. If I multiply that by 86,400, I get exactly 64,000. This is how many seconds are left from my operation. This is out of that big number I typed in, out of 31,600. Okay, this is equal to 365 days. If I subtract that, if I take 365 times, what is the result of this minus this? So 4,000. Okay, cool. Now what do I do? Why don't I take this number and divide it by how many? This represents how many hours, seconds I have left. So how many seconds I have left. So how do I figure out how many hours? So this is equal to, let's just say I have 365 days. How many is equal to how many hours? How do I find that out? I divide this, yeah. What do I divide that by?
16 and 24?
Yeah, seconds in an hour, 3,600. 3,600 is equal to 17 hours with a 0.777 remainder. $2,800. What is the remainder of 64,000? Then we do this operation here. This is our remainder. Okay, how many minutes are in that one? 46 minutes. Can we do this operation here? Well, how many seconds do we have left over? 40 seconds. So we have 365 days, 17 hours, 46 minutes, and 40 seconds. So we are able to take each of these operations and take the result of that operation here and use that in the next calculation. So we're going to mimic this step by step. We already did this part here. We know that it's that because it's 361,000 divided by 864. And this is divided by 3,600. Okay. This is the calculation we have to do at each step. And this number right here, you get by doing modulo. You take this, modulo this, will equal this. Okay. So this number is what we're going to calculate right now. So we're going to keep this off to the side here. I'm going to create a number called days remainder. Okay, given that you know what this number is and this number, can anyone tell me what this number will be? What will this number be? It's one of these numbers up here, one of these like 10 numbers up here. What will this result actually be?
6,400,
right? Right here. It'll be this number right here. Let's just verify that here. I'm going to put a breakpoint. So there's my days remainder, 64,000. Matches this. Cool. That means we can use this calculation to figure out how many hours are left. If we take this number, days remainder, like that, then we have that, we will get 17 hours. Same thing. If we create hours remainder, okay, and we'll repeat this pattern for Oops, minutes. Gotta do minutes. So hours remainder gives me how many minutes are left. Seconds in a day, seconds in an hour, seconds in a minute. Let's give me this. So now we can type out all of our pieces of info here. We can do days. I'm actually going to do these on separate lines here. Days. There I'm printing out. I'm putting these on different lines just because it makes it easier for me to read all on one page when it's zoomed in. Oops. This will be seconds remainder. "365 days, 17 hours, 46 minutes, 40 seconds." If I want to add days to this, or years, I'm just going to show you how you can do years. This is me doing extra stuff right now. You could do the same exact thing. And here, and here. And now I can print this out here. Like so. Now if I type in something much larger, I can get 1 year, 229 days, 21 hours, 46 minutes. So it keeps going. You can do decades, centuries, that kind of thing. The same concept applies. You're basically breaking down this big number into smaller and smaller and smaller and smaller numbers until you finally have something reasonable. We do this actually, like we have this code written because we store, like for say like we have this mode in Overwatch called Weekly Brawl, and Weekly Brawl runs on a timer. It basically says, hey, if a week has passed and we hit the time that we need to, switch over the brawl to the new one. So the interesting part is that all time, typically, when you're working with games, is represented on UTC, which is like the Universal UTC time. It's like coordinated universal time, universal time coordinated. So UTC is interesting because it's stored purely as it's basically there's like this thing, I think it's called the prime meridian. Somewhere over near England. UTC is a really, really big number represented in seconds. To show you how many seconds has passed since 1970. It's kind of an interesting thing. Unix epoch. I'm just going to take a little tangent here to talk about this. First of January 1970, epoch time. So there is a magic time, which is basically the year 1970 and the 1st of January, that things are measured against. It's basically the earliest representation of time that they had for computers. It typically was just because you couldn't represent time for more than it was a little over 2 years, like 829 days. So they didn't actually have enough memory to represent it. So they had to pick a starting point for this time. And 1970 was close enough so that it was able to represent most of the time that they're working with without having to go all the way back to the year 0. And it can represent dates up to 2038, January 2019. This time right here is. Any of you guys remember the Y2K problem about how people were worried about, oh, the year is going to roll over from 1999 to 2000? So this is kind of like a similar problem. Basically, we have all these times that are based off this point from 1970. Problem is it can't represent anything past the year 2038. So when we hit that year, January 19, 2038, it's going to roll over and start over at 1970 again. So who knows what kind of problems it's going to have. Kind of an interesting issue to keep in mind. So you'll probably start hearing about it on 2037. So 20 years from now, you'll start thinking about this. So think back to this day.
Is that in the world again?
Yeah, 2038 is, I think, pretty interesting. Yeah, 20 years from now is crazy. So let's take a break for now. Let's take like a half-hour break, come back. I have a lecture planned, so we're going to go over structs and functions, and then I have homework and lab. So meet back here in half an hour.